And here's Hess's law number 8. This one has a lot of shuffling pieces, so I'm going to go ahead and not take any shortcuts. But we're going to go ahead and solve the way we've been solving the other ones. I see hydrogen chloride gas in my reactants. I have 2 of them in the products. Here, I need to flip this guy and then also chop it in half. Since we're reversing the reaction, we're going to have to flip the sign of the delta H. So that's going to give me, instead of 2 HCl's, I'm going to have just 1. And I'm going to have half a sodium oxide. We're going to have only 1 NaCl, and we're going to have half a water. Delta H is going to be half of negative 507 kilojoules, which is a negative 253.5 kilojoules. So now I've got my HCl's. I also magically have that sodium chloride sitting in here, so we can check that off the list too. Next up, I need to get rid of this sodium oxide. I need to get rid of this half of the water. We also need to throw in some sodium nitrite and this nitrous acid. So let's go ahead and find sodium nitrite. It's right here. So I'm going to go ahead and, again, because I have a reactant here and I have a product here, I'm going to flip. That minus is going to become a plus. I have 2. I only need 1, so I'm also going to chop it in half. So when I rewrite this guy, I'm going to have only 1 NaNO2. We're going to have half an NO, half an NO2, and half an Na2O. Delta H is going to be half of positive 427, which is going to give us a positive 213.5 kilojoules. We already have a little bit of magical canceling happening. My half a sodium oxide here, my half a sodium oxide here, gone. So I've got my HCl and my NaNO2. HCl and NaNO2 are good. Sodium chloride is good. I just need to add some HNO2. I need to get rid of all those extra pieces. So let's look at this next equation. I have some nitrogen monoxide here. I've got this nitrogen monoxide here. So I'm going to leave this in the reactants, but I only want half, so I'm going to chop it in half. Half of negative 43 is going to give us negative 21.5. When I write this guy out, we get half of NO and half of NO2 is going to yield half of N2O and half an oxygen. So what we cancel out here, we got rid of half an NO and half an NO2. I've still got the hydrogen chloride that I need, the sodium nitrite that I need, the sodium chloride that I need. I still need to find this guy, and I need to get rid of these pieces. So now we're going to use this last equation. I have 2 hydrogen nitrites. I need to get rid of one of those. So I'm going to go ahead and chop it in half. This guy is in the reactants. I need him in the products, so we're also going to flip the direction, which means that 34 is going to become a negative 34. So rewriting this, I'm going to have half an N2O, half an oxygen, half a water, which is going to yield just 1 HNO2. Delta H, oops, I forgot to write that one. This delta H, do this guy first, is going to be half of negative 34, which is going to be negative 17 kilojoules. And this guy I wrote up here, half of negative 43. We didn't change the direction, so we're going to keep the negative, not flip it. Half of negative 43 is negative 21.5. So So now what can we cancel out? Half an N2O and half an N2O. These guys are gone. Half a water and half a water. These guys are gone. I also got rid of that half an oxygen and that half an oxygen. All that we have left is that HNO2. So we have HCl, NaNO2 is all that's left in the reactants. NaCl and HNO2, all that's left in the products. So all we need to do is add up everything. Negative 253.5, positive 213.5, negative 21.5, negative 17 is going to give us a grand total of, looks like a delta H of negative 78.5 kilojoules.